Okay, so in this video we're talking about solving linear inequalities. So first, what's an inequality? Well, to answer that, you might want to remember what is equality. What's an equation? Equality means balance. So inequality means unbalanced. Okay, so here, equation, balanced on both sides of your seesaw. Inequality, one side's going to be heavier than the other. Okay, so what's a linear inequality? Well, it's something that just takes this format, so y mx plus b, okay? Now, that's just an inequality symbol. We know we have other symbols, but that's just an example. So what's a solution? Well, it's just numbers that satisfy the inequality. Essentially, so we make a true statement on both sides. I mean, just like we did with equations, and then how we graph the solution of an inequality. For now, what we're going to be doing is using number lines. But eventually, when we go to two variables, what we're going to do is we're going to use a grid. Okay, so for now, number lines, eventually, later on in the course, a grid. Okay, so right now what we're talking about is operations that prove equivalent inequalities. So if we add, subtract, multiply by positive numbers, or divide by positive numbers, essentially the inequality symbol stays the same. So the inequality symbol stays the same. Now, over here, if we multiply by negative numbers or we divide by negative numbers, the inequality symbol will flip directions. So we're just going to say flip. So for instance, if I had this, then I would flip it to that. If I had this, I would flip it to that. Okay? So add, subtract, multiply by positive numbers, divide by positive numbers, you keep the inequality the same. Over here, if you multiply by negatives or divide by negatives, you flip the inequality symbol. So let's do an example. Okay? So just like when we solved equations, we want to get our variable by itself using the reverse order of operations. This shouldn't be too hard. First step, adding to both sides. So we have 5y is less than. Right, better than that. 5y is less than 20. Now we need to get y by itself, so I'm going to divide by 5 on both sides. So y is less than 4. Now we want to graph this on the number line. So I'm putting 0 here. Obviously, 4 is to the right of 0. Now, this symbol right here says y is less than 4. Okay? That means 4 is not included in my solutions. So I'm going to put an open circle since it's not included. And it says y is less than 4. Well, I'm going to go to the left then. Okay, so shading that way. That should look very familiar to you, shading using the number line. Okay, let's go on. Solve this one. Hey, we got variables on both sides. We know how to do this. We solved equations like this. Solving inequalities like this, same thing. Get your variables on one side. Get your constants on the other. Okay? So, getting my variables on one side of minus 6x, cancel out, so I have negative 4x. Okay? Over here, now I need to add my constants to both sides, so I need the minus 1 cancel out. So I have negative 4x is less than or equal to negative 2. Alright? Well, I need to get x by itself, so I have to divide by a negative 4. Cancel out, so x. Now check it out. I divided by a negative 4 on both sides. Well, our rule says when you divide by negative numbers or multiply by negative numbers, you flip that inequality. So I'm going to flip it around. So I have negative 2 divided by negative 4. That's positive 1/2. So x is greater than or equal to 1/2. So let's graph this one. Here's 0 and 1/2 is really close to that. Got it? Well, since it's greater than or equal to 1/2, 1/2 is part of my solution set. So I'm going to draw a closed circle at 1/2, and it's greater than, so I'm going to shade to the right. All right, so what's a compound inequality? Well, that's essentially when we're looking at two or more inequalities at the same time. So 2 or more at the same time. Two or more inequalities at the same time. How do we graph a compound inequality? Well, we're going to use a number line, just like we did before. So number line. Number line, we're going to shade, just like we did before. And, you know, for certain problems, we're going to look for the overlap. Other problems, we're not. Okay, we'll talk about it. So, what is an and? Well, an and is just something like this. All right, we got x is less than or equal to 4. X is greater than or equal to 0. Something like that where your constant, or sorry, where your variable is in the middle. So how does the word and help us do that? Well, when we see the word and, we're thinking of overlap. We're going to split our inequality into two pieces, which we're going to see in an example in a minute. And we're going to be graphing both of those pieces, and we're going to be looking for the overlap. Think about Thanksgiving dinner, and you want ham and turkey, okay? If you don't have both, you're going to be unhappy, you're going to throw a fit. That's what we're doing here. We're looking for the overlap, the pieces where we have both graphs. Otherwise, it's wrong. We're going to be unhappy. Now, kind of a similar idea, the word or, we're just going to have like two inequalities, so, I don't know, x is greater than or equal to 0, or x is less than or equal to 4. Now, that's just an example. But the word, so when you think of or, it's like when you're going out in public. They may have turkey or they may have ham. If they don't have both since you're out in public, you're not going to throw a fit like you would when you're just at home and you're in your sweatpants by yourself. You're going to be nice and proper, like, oh, okay, that's fine, I just have turkey. Or, oh, that's fine, I just have ham. You're not going to throw a fit. So either piece of the graph makes us happy, so we're going to show both. If you're over here, you're happy. If you're over here, you're happy. As long as you're on part of the graph, as long as you're included somehow. So let's do an example. So solve this one. So you see here, my variable is in the middle. Variable is in the middle. Well, that means I'm thinking about and. So when I'm thinking about and, I'm thinking about overlap for my graph. Okay? So what I'm going to do, the easiest way to solve these, and I advise you do this too, is you split this up into two inequalities. So I have -2 less than or equal to 3t minus 8. And I like to write out the word just so I'm sure I'm thinking about 3t minus 8 is less than or equal to 10. Okay. Now you just simply solve both of them like we've done before. So add 8 to both sides, so I have 6 less than or equal to 3t. Solve this one by dividing by 3, so we have 2 over here. Okay, so you got to be careful over here. My variable is on the right. Now I know we typically over here in America we read from left to right. But when we're dealing with inequalities, there's an exception. We need to start with a variable when we read. So t is greater than or equal to 2. Okay, be very careful. You always start with a variable when you read. All right, so now solve this one. So add 8 to both sides. So 3t is less than or equal to 18. Divide by 3 on both sides. So t is less than or equal to 6. So what we have here is t is greater than or equal to 2, and t is less than or equal to 6. Now you can put this back together. You can say t in the middle, less than or equal to 6, greater than or equal to 2. I don't advise that. This is perfectly fine what we have right here. And. That's perfectly fine, totally. But you do need to include the and, so I know it's an and problem. Also, we need to graph it, so let's graph. Put 0 in here just so for a place marker. So we know 2 is somewhere about right here, and 6 is somewhere about right here. All right, for the first one, t is greater than or equal to 2. Well, 2 is part of our solution set, so I'm going to use a closed circle. It says greater than, so I'm going to shade to the right. second one over here, t is less than or equal to 6. Well, 6 is part of my solution set. So I'm going to do a closed circle. And it's less than, so I'm going to go to the left. So now I'm looking for the overlap. So my final answer, my final solution set, are my 2 and 6 are in there because they were part of it, but it's also this overlap. So that piece right there in the middle where they overlap. And that's and. Okay. Now here in this problem, this example, we're solving an OR problem. And it's pretty easy, just solve both like we normally would. So subtract 3 from both sides, so 2x is less than 2, divided by 2, so x is less than 1. Or solve this one, add 7 to both sides, so 4x is greater than 16, divide by 4 on both sides, so x is greater than 4. Okay, that was really easy. Now we just graph both. So 0 is here, 1 is here, and then 4 is about right here. Okay, for the first one, we're saying less than 1, so 1 is not part of the solution set, so I'm going to use an open circle. And we're also saying it's less than 1, so I'm going to shade to the left. For the second piece, I'm going to say, hey, greater than 4, so 4 is not part of the solution, so I use an open circle. And it's bigger, so I'll go to the right. Okay. Final answer, don't forget the box like I just did, so be sure you put it in a box. Now what this graph is telling us, hey, I go to the restaurant, I'm out in public, they have ham, I'm happy, or they have turkey, I'm happy. As long as I'm represented somehow, some way, I don't really care, but I need to be on part of this graph, so either over here or over here. That's it. So that's it for this video. That's graphing inequalities.